Hello children, today I am going to discuss with you a very important topic on physics, that is current electricity. Now in our daily life we are very much dependent on appliances like tube lights, fans, refrigerators. Can we think of our modern life without these appliances? No. So all these appliances run on current electricity. So it is very important to know about something about current electricity, and in my video I shall try to give you an introduction to current electricity, a physical interpretation of current electricity. So the question arises, what is current electricity? Now the answer is, a continuous flow of electrons constitute current electricity. Now why will electrons flow? Just like water flows from higher level to lower level, in the same way, the electrons will flow from a place where there are excess of electrons to a place where there is obviously a deficit of electrons. Now, if a bulb is connected by means of a copper wire to a power source or battery, and if the circuit is complete, that means there is no discontinuity in the circuit, then we will find the bulb glowing. This indicates that current electricity is flowing through the wire and then through the filament, which is connected to the wire and to the battery, for which the bulb is glowing. Now since current flows through copper wire, we can say that electrons also flows through copper wire. Now from where do electrons come in the copper wire? Copper is a very good conductor of electricity, and metals like copper, silver, aluminium are also good conductors of electricity, which means that there are electrons that flow through these conductors. Now from where do the electrons come, which are free to move? From where do the electrons come which are free to move? Generally we know that in an atom, the nucleus attracts the electrons that revolve around itself in the orbits. But we also know that the force of attraction gradually decreases as the electrons move in the bigger shells, means the outer shells. The force of attraction on the outer shells decreases. So in copper, in metals, the single electron which is in the outermost shell of the copper atom is loosely bound. So what do we mean by loosely bound? That means if we bring another strong attractive force in the vicinity of the free electron, the free electron will just strike off its orbit and it will be free to move. So the electrons in the valence shells of such metals are loosely bound to the nucleus, and these are free electrons which are attracted in a field created by positive charges. That means obviously positive charges means where there are depletion of negative charges, where there are depletion of electrons, they are attracted towards that side. Thus there are free electrons in metals, and there is a need of some force that will trigger the motion of the free electrons. Now who supplies this driving force? This driving force is supplied by the power supply or battery, which is connected to the wire. Now there are two terminals in the battery, a positive terminal where there is deficit of electrons and a negative terminal where there are surplus of electrons or excess of electrons. Thus, due to the positive and negative terminal, due to this balance in the number of electrons, a voltage difference is set up between the two terminals of the battery, and when it is connected in the externally by a wire, then what happens? The positive terminal of the battery triggers the movement of the valence electrons in the conducting wires and attracts them. So the valence electron of the atom of the metal atoms are kicked off its orbits and it again disturbs the neighboring valence electrons. This results in a continuous flow of electrons through the conductor from the negative terminal of the battery to the positive terminal of the battery. Why negative terminal? Means there are excess of surplus of electrons, so from there the electrons continuously flow through the wire and even the free electrons are moving through the wire towards the positive terminal. Now, conventionally, we say that the direction of current electricity is opposite to that of the flow of electrons. Now, with this, I finish off with the physical interpretation of current electricity. Now, in my next video, I will give you the mathematical expression for current electricity. Thank you, children.